Okay, now that we have an understanding of what the set operations like union and difference and intersection and complement are, now we're going to look at some expressions here like these where we're putting these operators together. We do have to think about an order of operations, so we generally want to do any complements that we see applied to a single set first, and then follow what's in the parentheses, and then perform the rest of the operations. It's not going to be quite as complicated as the rules we have for arithmetic with order of operations. What's important to understand is the placement of the complement. If you notice in part A here, this first exercise, the complement is over the union. Now what that means is you're going to take A union B first and then take the complement of it. Okay? Now if you look in part C, both cases the complement is directly applied to one of the individual sets. So for the group in parentheses over here, the expression in parentheses, you're going to do the complement of C and then union that with B, not the union first and take the complement of the whole thing. The complement here only applies to C. The complement here applies to the entire expression A union B. Now, if you have a bunch of these to do and you know there are going to be some complements involved, it might make sense right away to just have A complement, B complement, and C complement written out. If you only have to do one of these, you can just sort of do it on demand as it comes up. But just for extra practice, I'm going to go ahead and put the complements here. A complement is going to be 3, 5, 6, 7, 9, 10. Again, I have 4 in A, I have 6 in the complement. For B complement, I have 5 in there. So 4, 6, 8, 9, 10. That means 5 in the complement. And C complement will be 1, 2, 3, 4, 5, and 9. Again, 4 in C and 6 not in C. And then this way I have them ready if I need them. Again, you don't have to do this ahead of time. You can just do them as you need them. But I figured this is new to us, so let's just get as much down as we can right away. Okay, so let's deal with part A over here. We want to do A union B and then do the complement. So what we're going to do is we're going to start and we're going to use equal signs to chain these together just like we would with an algebraic expression. We're going to start with what's in the parentheses. I need to put together A union B. Okay, so I'm going to focus on that. That's going to give me the set 1, 2, 3, 4, 5, 7, 8. Okay, now I still need to take the complement of that. I'm not going to try to do two things at once. I'm going to first do the union part and then copy the complement down, and now I can perform the complement operation. Well, I can see 1, 2, 3, 4, 5, 6, 7 things in the union. That means there should be 3 things in the complement, and those would be 6, 9, and 10. Okay? So again, we did the union first, put them together, then we did the complement. I carried the complement operation down here because I haven't performed it yet. And then once I perform the operation, I stop writing it, and then I'm done. Okay. For this second one, I have to do A minus B, and then intersect that with C. And I want to do that in this order. I want to do the parentheses part first. So again, I'm going to start a chain of equal signs, A minus B. If I start with A, and I remove what's in B, the only thing I'm going to have left, or the only thing I'm going to remove is the 2. So A minus B is going to be 1, 4, 8. And I want to do the intersection of that with C, which is 6, 7, 8, and 10. Okay? So I got my A minus B over here. I have my C over here. And then I can perform the intersection operator, which is going to look for what they have in common. In this case, it's just the set 8. I can't write the 8 element without the set operation, set brackets around it. Okay? So in this case, I did the subtraction first, and then I did the intersection. Again, I'm showing my work here to do it in stages, just like I would with an algebra expression. And then I get my final answer. Okay. Now for this last one, I'm going to have to do A complement together with intersected with B union C complement. Okay? And I don't think I'm going to have enough room here, so let me move this a little bit. Move this one out of the way. Okay, so I moved it down here so I have a little bit more room to work. And I'm going to want to do A complement right, which I actually already have up here. And then I'm going to want to do C complement, which again, I already have the foresight to do that up here. But the thing I want to do first is put B together with C complement. So I'm going to start writing here. I want to do A complement, which I might as well do because it's sitting right there. 3, 5, 6, 7, 9, 10. I want to intersect that with B union C complement. So I want to put B together with C complement into a single set. Now they have a lot of overlap, the 1, 2, 3 and the 1, 2, 3 and the 5 and the 5. So I can really just throw the number 7 into C complement. That's the only new thing coming into C complement. So I'll get 1, 2, 3, 4, 5, 7, and 9. Okay? This here is the result of B union C complement. Okay? And now the goal is to do the intersection of these two sets. So I'm going to look for common elements. I can see the 3, I can see the 5, I can see the 7, and I can see the 9. Okay? And that's how we do these set operations. Okay? They can get more complicated, but this is about as good as it gets. You had 1, 2 set operations and 2 complements. It's important you understand the difference of placing the complement over an operation or a complement over an individual set. It's important that you work it out in stages and show your work. But otherwise, this is more or less all there is to it. Now, if you get to a point where you have an intersection, you always have to entertain the idea that the answer could be the null set. The complement could also be the null set. If A happened to be the entire universe, then its complement would be the null set. So as you're working along with these here, just keep in mind that if you see no intersection or you see no complement, you would put the null set down. But if you do the null set union together with another set, you're just going to get the other set. So just keep that in mind as you work through some examples.